Now the other reason why we did this problem is because if I had to make a circuit that did addition for more than one column, then I might want to reuse a circuit that I've already designed, right? So I just made a circuit for S, and I made a circuit for C1. What I'm going to do is I'm going to pretend that I had that circuit, those two circuits, I had them put on a chip, which I'll now consider to be a black box. And this is my adder. And by the way, just for anyone who looks at the book, they call this a full adder because it has a carry and the inputs. If it doesn't have the initial carry, it's called a half adder. But I don't like to do things halfway, so we're going to do the full adder. Okay. So that takes as input x1, y1, and c0, and as output we get s. Let's just put c0 over here, and we'll put c1 down here. So we'll get s1 and c1. So let's suppose that we wanted to build a circuit to do 2 columns of addition. So first let's write down what it looks like to have 2 columns of addition, and then we'll figure out how to make a circuit using this black box. Because it's a chip, now I can use as many of these chips as I want to. So I can write this here. We said that we had x1 and y1 and c0 for one column, and then we had s and c1 like this. So in the next column, I should have some more bits. The top row's x's, right? So this should be x what? X2, just anything besides x1, right? Because it's a different variable. And this will be y2, and that was s1. So this is going to be s2 as the result of that. And then we're going to have c2 as the carry. So if you look, our first adder will take the first column as inputs and give S1 and C1 as outputs. My second adder has what as inputs?
X2, Y2,
X2, Y2, and C1. And then I have outputs S2 and C2 again. So if I draw another adder here, let's put a piece of paper here. I know that my outputs are going to be S2 and C2, and I need to put X2 and Y2 here. And this is a carry bit. This has to be C1, but that comes from my other adder, right? So I'm going to take this wire and I'm going to hook it right up to this wire. So this is sort of my adder number 1. This is my adder number 2. So this does the first column, this does the second column, and I've just shown how we can add them together to make a 2-column adder.
What's that C in the middle?
Is that a
This
C?
C?
Yeah, C1.
This is C1. This is the output of the first adder, because it has a carry bit and a sum bit. It has a sum bit 1 and a carry bit 1.
Okay.
Because I put both of those circuits in there. We made a sum circuit and we made a carry circuit. We would put both of them in the black box and hook up these inputs to the circuits that we made. So there'd be 2 little circuits inside this box, and one would give me this output, the C1 output, and one of them would give me the S1 output. And in here it has 2 circuits also. It would take these as inputs, and one of the circuits would give me S2,
So
and one of them would...
C1 as the input to the second adder?
That's right.
Okay.
So this is nice because once you've designed a circuit, you can reuse it again for something else. For example, we could have made part of our sum bit, we could have made it with exclusive OR, because that's a circuit that you could use and reuse because someone's already designed the logic for it. So since there's already one, and the truth table looks like exclusive OR if we look at it. Let's take this off. If you look at that top part looks like exclusive OR, right? The second part looks like the opposite of exclusive OR. So we could have used some exclusive OR gates to make S in the first place. It's not wrong not to. It's just that we didn't use some. So I'm just saying that anytime you have something that you've already designed, you can use it again. And that might seem really obvious, but if you're doing your homework and no one told you that, you might not think of it.